How USB technology works. USB is one of the most successful technology standards ever created. It charges phones, connects keyboards, transfers files, powers accessories, links computers to countless devices. At this point, if a piece of electronics doesn't use USB somewhere, it almost feels like it's actively avoiding it. But behind that small connector is a surprisingly sophisticated communication system. So today we're going to look at how USB technology actually works. USB stands for Universal Serial Bus. The goal was simple: create a standardized way for devices to connect and communicate. Before USB became common, computers often required different connectors for different devices. Printers used one connector. Keyboards used another. Mice used another. The result was not especially convenient. USB simplified everything. A USB connection performs two major functions. It transfers data, and it provides electrical power. Some devices only need one of these functions. Many use both at the same time. Inside a USB cable are several wires. Some carry electricity. Others carry digital data signals. When a device is connected, communication begins almost immediately. The computer usually acts as the host. The connected device acts as the peripheral. The host identifies what kind of device has been connected. This process is called enumeration. A keyboard announces itself as a keyboard. A mouse identifies itself as a mouse. A storage drive identifies itself as storage. The operating system then loads the necessary software drivers automatically. All of this typically happens within seconds. Which is fortunate because modern users generally expect technology to work immediately. USB evolved through several generations. USB 1.0 provided relatively low transfer speeds. USB 2.0 increased performance dramatically. USB 3.0 and later versions became much faster. Modern USB standards can move enormous amounts of data every second. The connectors evolved as well. Early systems commonly used USB Type A and Type B connectors. Portable devices later adopted mini USB and micro USB. More recently, USB-C became the dominant design. USB-C introduced a reversible connector. No more turning the cable around repeatedly hoping this time it would fit. A surprisingly meaningful technological achievement. USB also became a major charging standard. Modern USB power delivery systems can provide significantly more power than earlier versions. This allows phones, tablets, laptops, and other devices to charge through USB-C connections. Data transfers happen through digital communication protocols. Information is divided into packets. These packets travel between the host and connected devices. Error-checking systems help ensure the data arrives correctly. USB hubs allow multiple devices to share a single connection. The host manages communication with each device individually. USB also supports hot swapping. Devices can usually be connected or disconnected without restarting the computer. This convenience became one of the reasons USB spread so rapidly. Today USB supports far more than basic peripherals. Video output, audio, networking, storage, fast charging, external displays, and many other applications. What started as a simple connection standard eventually became one of the most widely adopted technologies in history. Most people never think about the engineering involved. They simply plug something in and expect it to work. And remarkably, most of the time it does. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.